Okay, thank you and hello everybody. I actually thought it's going to be fewer people because it's the last talk, so I thought everybody's going to be asleep or not interested in the last talk, but here it goes. So the talk is called It Works on My Database. We will go through the topic. Agenda is quite simple. I will first introduce the problem, why I believe it's something we need to pay attention, not just now, but going into the future. And I will propose you a solution, which I've been working on. So as Tomáš said, you don't have to remember my name. I'm branding myself as a boring SQL. I'm actually not using the boring SQL. I'm saying it's a boring SQL because it's the second part of my life. And that's supposed to be a boring without incidents and without any surprises, which I don't want. And, my goal is to my goal is to show people they don't have to just make same mistakes because if I'm guilty of something is all the stupid things which I did when I was young, and I believe I need sexy things. I need to have the latest trends. I need to have those things that you just implement and everybody will see how such a genius you are, but they actually don't work. You just need a nitty-gritty things that you go forward. And this is the boring SQL all about. So you might have read some of the articles. They usually tend to somehow, I'm not sure why, score quite nicely. But just to know if you pay attention, what was the root cause of your last database-bound incident that you can remember? US East 1. Who suffered some disaster because PostgreSQL faulted? Nobody. Yeah, that's how it's supposed to be. So who had a problem that configuration wasn't right? Yeah, okay. Now we are increasing the chances. But who had a problem that actually query went badly or migration locked everything for minutes and everything came to halt? Yes. Okay, yeah, more people, more hands up. Yeah, thank you. Because this is the statistics I'm kind of keeping up. We don't have an issue, and I will repeat this one many times. Postgres is an amazing piece of technology. It won't crash on you unless you do something very stupid. Your operations, SRE teams, your managed provider, they will do fine. Even RDS, which I don't like, they will tune your instance for the most workflows and they will work. But it's the developers. And I have to apologize. Normally, I would ask who's developer, who's DBA, and I would badmouth developers all the time because they usually do bad things. I won't because we have a new villain on the block, so somebody else will take a blame. So what you have seen is 80%, and it's my number. I can tell you whatever I want. I can tell 105%. And you would still believe me probably. Everything goes down to queries and schema-related things. And, it goes to a concept that people are afraid of SQL. I was afraid of SQL. I spent literally first 10 years of my professional careers fighting SQL, trying to avoid databases. If you hear a stupid things developers say about databases, I told them all. I was the first one who jumped on NoSQL because that's the best thing you can ever do. I was the one that said, database is stupid storage, you shouldn't use it. I was a trainer of Hibernate. I literally pushed ORMs because I was afraid of SQL, because it's not the real code. We have seen the lightning talk, I think the Lutra was mentioned. This is what, we all will try. I'm not saying, Lutra is bad. I'm just saying we will do a lot of things when we are not old to fight things we are maybe afraid of. And I did it. SQL usually runs elsewhere. You can debug your code in your IDE. You can just breakpoint everything and you can do it. Developers do it very well. SQL suddenly runs elsewhere. And most likely you will ever, if you are a developer, you will never see the environment where the SQL actually runs. That's the most scary part. It might be completely invisible. If you are using ORM, you will hopefully, that's your goal. You don't want to see SQL. And I think this still applies. Education around databases and SQL is actually terrible. If you take I'm not talking about you guys, you are on the right conference, so you all know what you're talking about. But if you take an average developer, they are really bad in writing any queries. You will find, you can have a first 5 minutes looking at somebody queries, and you will see how they write. CTEs are a good example. They will try to put this procedural flow into queries because that's how they think. That's how they write the code. And you will see how that works. So you can have you talk with people, good CTEs, bad CTEs, and you have to explain there is not a single way how to do it right because it just might be different. So, having said all the bad things about SQL, which I actually like, I don't have any issues with SQL. We do a lot of testing, but how do we test SQL? Does anybody use pgtab? Okay, couple people. pgtab is I think, one of the ways how to test schema, how to test that something works, but you are still not testing the SQL itself. So we covered syntax, that's fine. A lot of people, if you are not using ORM, you might be doing things like writing SQL as strings in your source code. Yeah, that's the thing. And then, you have things that sometimes, you will get a syntax errors. That's, easy, you can get it. Somebody will rename a column and the application will never find out. How you will find this? No, you won't. There are actually legitimate reasons why people want ORMs, because, SQL is scary as it is. How do you maintain that contract is maintained, that whatever you return is what you expect? You can have a unit test, you can have an integration test, but, coverage is pretty difficult, but coverage doesn't tell you everything. It doesn't tell you the whole story. So you need to make sure that you have everything done. And do you actually test how the query will behave? I haven't seen it. So if you know a software development team that actually tests this, please let me know after the talk. I would actually be interesting. But the thing is, having said all that, who is writing your SQL queries? If you are, yes. Okay, I will actually get to it. It's part of the whole flow, so we will cover it. I can spoil it. It's actually all about time, all about cost, and when you capture issue. So who's actually writing the SQL queries? 5 years ago, I would say developers who have this terrible SQL education, they actually hate databases. So you can hear it, it's not something that, who was at any point afraid of joins? Yeah, that's the thing, I know 3 people, not including anybody in this room, who do anything in the SQL query to avoid another join. If they see an 8th join in a query, they will try to do something. Usually it will end up in a very stupid thing because they will write a nested loop somewhere and it will crash. They won't see it because it works on their machine. ORMs. If ORM writes your query, you might never seen SQL. You might have seen it in error messages coming from the server, and you will blame Postgres. You will blame any database for it. But these days, there's a new villain on the block, and that's called LLMS. AI. Okay, I can't pronounce it. Again, some stats, I Googled this one. 84 developers use AI in some sort of way, either via chatbot or via agentic mode. If you just touch the topic, I've seen surveys from mid-sized companies, and what are the benefits of AI? That was the question. almost every single developer write, it helps me to write better SQL. So suddenly people are not writing SQL. Suddenly some clever machines that have to burn half of the glaciers to give you answer, they will write the question. I'm actually not against it. I think it solves the syntax issues. A lot of people will have an issue when it comes to syntax, advanced SQL constructs, windowing functions. They can actually do much more. So I actually believe something like this can happen, and it's actually working. The LLM, you just ask, I want a query. This is maybe the table, so you will copy paste something. You will extend the context of the question, and you will get a query. That query will look, in most cases, completely reasonable. So you don't have to do any problems like Stack Overflow. You don't have to, you don't have to think. But the problem is, amount of changes, the rate of changes is increasing. So AI is writing code, AI is writing a SQL queries, AI is doing a review. And well, for me, it's a benefit because I don't have to, badmouth software engineers in general. But suddenly the landscape is changing. What can actually happen is you suddenly can, and I do apologize for the examples because the real examples happen in production. This is just a simple one. But you can have somebody who doesn't understand a change. This would be a regular business change. You have a query that returns you a data. There's an index on created that. You display something for last one day. It will work fine. But somebody will just add order by because you want to see either by latest or by total amount. Who would index it? The difference is the query will be technically correct. The integration test and everything will be fine because you will write the specification. If you are TDD, you will write it first. So your CI will be happily ever after. You deploy on Friday, and on Monday, you have a production incident because one query that used to take 1 millisecond now takes 800, 900 milliseconds. It's fine. If you are two transactions per second, nothing will happen. But if you are in a matter of hundreds transactions per second, thousands, this will eat 3, 4 replicas, just this small change. And you will see, everything erroring, query timing out. Hopefully you all have the statement timeouts and all the timeouts for it not to escalate. But this is what will happen. Your test, as I said, work. But what actually happened? If there's one thing, and Deva talks about it throughout the day, learning, explain, and reading it is actually essential. But ever since Postgres 18 started, the buffers are by default. And we will actually talk a lot about buffers. So you just need to know that change, I think in this case, you just started reading whole table. That people might not realize because they limit something by top 50 records. But they actually have to read much more data. Buffers is what has changed. So your server suddenly will start doing much more queries. And if you go back to thinking how developers reason when they tackle the SQL, and that's the reason why somebody would write a query and then be surprised, because they don't care. They think in a procedural programming. They think, I will do this, and then limit. Sometimes they don't get the reason that, you're not saying how to do it, you're just saying, what do you want? And then Postgres will figure out, any database server will figure out how to do it. And this is the main issue, because even on your machine, if it will work fine, you will not notice the problem. Behind the scene, any complex query can switch the behavior. The plan can change based on the data structure, based on the cardinality of the issue. And developers can't say this one. We have seen it, right, Teresa? We have seen it like having clones, having access to environment. So very often you will see a developers asking for I want to have access to something like production database. Why? Because they want statistics. Same query that runs on their machine might run completely differently on a production environment. You will never have a completely analyzed table. You will never have statistics that are same as on your development machine. If you have 10,000 records on your development machine, you can have a billion records on a production. And who knows when the auto vacuum had the last time to update statistics. You can have a high cardinality columns like statuses. They can change. And just by having that cardinality column change the statistics, it can completely bypass your regularly working indexes, and you will start fighting it. So one query can have multiple realities. And that's why it works on my database concept. We have solved it, and if you are in industry long enough, you know this is not a new statement. It works on my machine was something that Docker actually pioneered. Because previously, developers shipped something to operations team, they deployed it and it didn't work. Maybe it didn't even compile. That was a different reality. We have it for our staging environments. We have a feature flags. We can gradually test changes. Sure, we can do things like this one with the queries, but what about the data? You will always have a gap. So I'm not saying I have a solution. I'm describing the problem. Code review we covered. Let's just skip this one. So there could be a easy solution. Before any chance, just run, explain, analyze, and you will be fine. But how are you going to do it? So you can implement your systems that will somehow extract the queries. You can implement the system to work on it. You can then have to work with at least JSON explain output. You will have to do all this. And you need to focus on what to test. So effectively, when I'm going to talk from now on about this SQL query regression testing, I'm going to talk about the logical correctness and performance. Logical one, it might not be surprising for you because this is what you have mentioned. You can write a unit test. You can write integration test. But the only issue is when you come to a normal integration test, they are very slow. I haven't seen integration tests that would run in seconds. Usually to spin up database, to seed data, it takes time. And the more realistic scenario you want, the more time you will spend actually on doing this one. You can do cloning of the databases to make it faster. There's a lot of small steps you can do to actually make it better, but you will still have to reinvent the wheel. So from all I know, every company has their own system how to do it. They starting with their own data sets, and they do it. But, and this is where this talk comes, how do you measure performance? When I wrote the article, original one, many people told me it's not possible. This is impossible. We can't do it. But this is my relationship with the Postgres, because Postgres allows this one, and every single version it gets better. What you can do, what's the performance for you? For us as a humans, it's a time. So when we perceive something is not working fine, we only see, how long something takes. But how do you regress test a time of the query? It's virtually impossible. Every single query will work differently. You will either hit the physical storage, you can use the share buffers, you can be on we developers, most of us have Apple Silicon machines. They are super fast. Like literally the I/O is, unless you have some dead-end M2 machine, they are super fast. Like every single test on the Apple Silicon is just fastest. Then you can run on some ARM server somewhere in the cloud where you share something with a noisy tenant, and that will completely change. So how do you say, what would be the acceptance criteria for query that changes? Because as you can see, you can say, can test fail if the query is 50% slower? But what does it mean? That means like every day you will have 3 false positives, somebody will have to go, and the outcome will be everybody will be ignoring the tests. So they will. So cost comes as a natural answer. That was actually my natural instinct to start measuring cost. So if you run explain, you see the cost. But when I did, I actually, that was my learning path. I had to learn more about Planner, how everything works. And for me, and that was my, again, stupidity, because I thought cost is realistic. It is, but it's only before executing the query. That's the estimate. So I needed to look into something that actually is going to be much more predictable. And that's where the buffers came. And buffers actually are the simplest thing, because no matter if something is cached or not, you see how much data needs to be moved. There is a tremendous amount of detail we can go into it. We can discuss the shared buffers. You all know how to probably set it up. That can affect the performance, so that will affect the timing. But the amount of data will always be the same. So if you know that a query takes 56 pages, it will always be 56 pages. There is no way out of it. So that's the only number you can actually use, as you can see across the different systems. If you have a fixed and predictable environment, you can focus on timing. You might be able to focus on a cost, but only real number you will get from explain analyze buffers is number of buffers. You have to take the total, because we don't care about the shared buffers. You can have a different characteristic, but those are configuration management. So for example, if you take a shared buffers, you can have a write of the dirty buffer when you're doing a read, because something needs to be evicted from the shared buffers. This is like my last article, so if you want to learn more about shared buffers, you can just go there and learn. There's even visualization that runs like in the browser. But buffers don't change. You have total, but whatever is going, it's fine. But we don't care, because this is the part where all this AI Postgres configuration actually might come. So if you trust enough somebody to auto-tune your Postgres, this can be actually solved problem. But if you send a query which is unpredictable or has a bad patterns, you won't stop it. And no matter of automation in production will actually solve it. You can add more storage, you can add more memory, you can have more replicas, but you will still have that problem. You will have to deal with it. So regression on the performance level is if your number of buffers from a given point changes. So if you have a query that has 100 pages read and it jumps to 150, you can reasonably predict that no matter what you're going to do, the query will be faster, because server has to do much more work. I/O is not, we are not in the spinning disk times where, you would hear the hard drives like, crunching through the data, but it's still not for free. So you still have to transfer data. If you have thousands of transactions per second, you will still have to wait. And if one query jumps by 50%, you need to somewhere take that time. Your CPU will be in I/O waits time, and you will be waiting. This is the reason why one query on a busy system can actually slow down and have an avalanche effect, because you will take the time from something else. So that was the problem. And there is I believe, solution, and it's a work in progress, because I wouldn't never actually go live with it. So somebody forced me to do a show what are you building. RegreSQL is not originally my project. If you have read The Art of Postgres by Dimitri something, it's one of the popular books in how can you learn working with Postgres. He introduced the RegreSQL or RegreSQL. I tried to commit patches for it for like 4 years, but he literally evaporated from planet of Earth. So if he hears this presentation, I will be happy to talk to him, but I'm just telling it on every single occasion. I never heard from him. So what I did after all those years, I forked the project and started working on it. So original idea was Postgres has a very nice regression testing system. And he did it for queries, but he only did it for output. So where I started was adding the performance layer. And as I said, I started from when I introduced it 3 months ago, it had only explain. So everything was cost-based. Then I started adding buffers. And part of this is making sure everything works. And all what I said is now available on GitHub. You can try it. I would say the documentation sucks, but in the Q1 of this year, officially version 2.0 will be released, and developer experience is what I want to focus on. Effectively, it's a very simple tool. Part of the changes is I'm trying to change the logic to be closer to to Git. So previously you had different commands. Now it's more like a Git-like experience that you just initialize the project, you configure it, so you can see you have a database which you are using. You have a configuration of snapshots. So when I said that you need to have a one given point, it has a support to manage for you the snapshot, where you're starting from. So what it has is ability to call external tool. If you have a migration systems or seed in something, it can call that tool to provision that data, and it takes the snapshot. So every single test will record not just the data, it will take the server configuration, because you want to see that what was changed, and you want to see as little changes as possible to have reproducible tests. And it has a support for fixtures. So one of the biggest issue is that you need to somehow see the system. So right now there's a YAML-based system that can generate, I think now 22 types of data, ranges, randomness, and everything around this one. And you can put it. This is the part where you test. And as you can see in version 2.0, analyze, enable. So this is effectively what switches from the cost to buffers. Then the flow, as I said, I'm trying to get it closer to Git. So you have a snapshot management. There's a whole savings, restoring, testings. There are hashes to make sure it's all consistent. But there's a discover. Discover is part where it will go and try to discover all your SQL files. Hold the question, I will answer that later. So right now it expects to find your queries, not in the source code, but in the SQL files. This is one of the thing I mentioned. So for example, for Go, there's a library I also have for it that enables you to save it. For TypeScript, you can do the same one. A lot of frameworks had the same support. And then previously, it tested always all queries. Right now, you have add, remove. So you will effectively stage the queries and run them. Update and baseline, we will cover, because effectively, this is the output of Discover. So what you will see what the RegreSQL can see in your repository. It will try to find all the files, and this is where the tests start. You can see there's a one query per file, but you can have a multiple queries per file. It's using a known convention how to name the queries. And once you have a file added into a testing, you need to create a plan. So how can it test queries if it wouldn't have input data? Because your queries are most certainly parameterized. So you need to provide a data. So same as you do with any other testing, you will provide all scenarios. So you will provide values for all your input values. And those will be run for every single test against your snapshot. So we have covered, you have a predictable starting point. You have a queries which can be parameterized. You can do a queries that are wrong. You can test a injection. You can test anything you want. And this is, for example, where LLM is actually very good. You can write 4 tests. That's easy. But if you want to write 100 tests, it's actually going to be difficult. But you can actually prepare prompt to write you plan files quite easily. So not all bad about LLM. And then you run it. So this is the easiest thing you can see. Unfortunately, I can't see it because my eyes are tired. So it passed. What it did, it validated that the test output is the same one as the first time you run it, so you still have the same data. It compares the buffers. There is a configurable threshold of 2%. So you can still say, if the buffers change is within 2%, don't even bother with it. That's still considered pass. And one of the important thing is it has, right now, it's a limited, but it understands the explain output. So it can already detect scenarios where your queries might be wrong. They are still fast, but they might hit you at one point in future. So in this case, you can see all the explain analyze output has a sequential scans. You can configure it to trigger this as an error, so your CI would actually fail. But this is the example of the queries. I would like to say that most of the production incidents are very complicated queries which are not unpredictable. But if I take last 10 database-bound issues I've seen, they were all very simple. Query plan change, something, start doing sequential scans, response time elevated, servers got saturated, timeouts starting kicking in. But this wouldn't be all, because you can say, if you won't have a 10 terabytes snapshot to test the production, you won't have the messy statistics. And this is where Postgres is the best thing ever. If you read the Postgres release notes, the PG upgrade in Postgres 18 can retain statistics. If you look behind the scene, those are the two functions that are applied. So you don't longer have to analyze your cluster when you upgrade with Postgres 18. So right now it's a manual. You can run such a query on production. You can get from any single replica the same statistics. You can package them as a SQL file, and you can just supply test minus stats with that file. And RegreSQL normally with a snapshot would do analyze. In this case, it would reapply the production statistics. So what you can effectively do, you can force on a much smaller data set. You won't have the same buffers because you won't have the same scale. But because you have a fixed snapshot, you can apply statistics which are in production, and they can be very messy. You apply them on developer machine or CI machine, and suddenly you have a full circle working regression test. I've tested it, and I'm happy. I wouldn't be telling it if it wouldn't work. It actually can take the mess which is in production and apply it to developer machine. So as I said, this is the RegreSQL 2.0. This morning I pushed the 2.0 alpha 1. I made a bug, I pushed alpha 2. And as I said, it's not about the code. Anybody can write the code. So now it's actually about documenting it, landing all those flows, and helping you to get started. Because this is not a silver bullet. You have to do a lot of work to get this working. You have to get your queries into SQL files. You have to get plans right. You have to get your CI set up. So it's a plenty of work. And the abstract for this talk would be lying, because I mentioned it can do it for ORMs. Because non-trivial number of people are using ORMs. So next work that I have to do is to support most of the ORMs to actually extract the queries. There are other mechanisms, like I can tap into a connection poolers, I can do a extension in Postgres, or just read PG stat statements. I can do a lot of things, but if I capture it directly, so one of the work in progress, which is almost done, is the regress active record for Rails. And it can effectively translate. You have to help it. You have to do a little bit coding on the side, but it will actually allow you to run rake in Rails project, and it will export you all the SQL queries that you have. Once you have the SQL files, you know where it's going. It can be used by RegreSQL, and it can be tested. I know that there is a plenty of ORMs that needs to be supported. So I'm already looking into doctrine, how to do it, and I'm looking into ways how LLMs can be used to extract the patterns and actually generate it. So it's all about automation. So LLM is not a villain here. It's it can help us to extract the patterns, what is being queried in the non-SQL way, and translate it to SQL, because I need that help analyzing the source code. So just by question, what other ORMs you guys are using? Nobody's using ORMs. Okay, perfect. So as I said, yeah, there's a plenty one. I think Hibernate is high on the list. Doctrine, PHP world here is actually quite popular. As I said, everything is about improving better developer experience. So no matter how much work I will do into tool, it won't be usable if there is no first-class support for it. It's open source, so actually there is no sales guys who would deploy your professional services team to implement it. So it needs to be fine. There is a known issue. Fixtures are not fast today, because I still took the original code which was there, and it's using one inset after another. So generating it's a big time. It takes minutes. I want to create a better time, better fixture support. Maybe it won't even be a Go. Maybe it will be something different. But I want ability for you to say, I want 1 million random orders with 10,000 of customers and generate this one. Again, the fixtures work and definition, it's all your work. You can use LLM, but you still need to define it. And when it's actually moving, and I was surprised by this one, because when I published the article, I have to say it's not my idea, because when the article went, I had 10 VCs emailing me, and they came up with a term which is called contract governance. People literally see increasing amount of LLM-generated code that is being reviewed by LLMs, and how those companies, like financial institutions, how they make sure they cut the testing time and still make the queries behave as they expect. They still return everything as expected. So this was a small introduction, and there would be 3 hours of talking. If you want to hear more details, you can listen to the previous Postgres FM episode. We have talked with Michael and Nick about buffer specifically and why it's so important. So you can listen more details, and more blog posts will come on this topic. If you want to use it and have any issues, drop me email, open GitHub issue, and you can do it. If we still have a couple of minutes, I can show you a few examples. So this is the part where everything goes wrong. Let me just switch to my terminal. So first, I will do a test. So this is what you have seen on the slide. So effectively, you might have seen it when I ran it. It was restoring the snapshot. Snapshot in this case is 10 megabytes. So it effectively took the data. It's the predictable state. It ran 8 tests. There is effectively 1 query being tested. 8 is because I've defined 4 plans, as you have seen on the plan file. But there would be 4. But another 4 are the performance. So for every single plan variation, it will actually test the buffers, cost, and full explain analyze. And as you can see, it actually highlights the sequential scans. What you can do, in this case, I will do, this was a perfect example. I actually omitted lower, because that's what we're using. So now you can see all tests suddenly stop saying there's a sequential scan, so you have fixed it. But it wouldn't be a regression testing framework if it wouldn't be saying you might need to update your baselines. Because if you start, and another, you can read a PG Mustard article, if you hit index scan, it doesn't mean your query is going too fast. It's going the fastest as possible. It can actually be always faster. So if you actually improve query, you can update individually per each query the baseline. So what you can do is run RegreSQL baseline. I hope it works. Yeah, so it run analyze. And now you can see you have a new state. You can do it for all queries, but you can do it for single query because it should support the developer workflow because you never work on all of them. You just work on one. So this was the part of the performance testing. Right now, it knows the sequential scan. It looks into a number of rows dropped along the way. So for example, if a query reads a 5,000 rows but uses only one, you will see it as a soft warning. So you have all those. So one of the supports I need to do is increase the support of explain output. And actually, that's what we're going to work with the PG method most likely. I can't tell from Michael's point of view, but we are both interested about it, to add a better understanding. Because context, suddenly, when you're talking about a debugging query, if you do it in LLM, you have usually query and the query plan. It works most of the time. But if you have statistics, if you have schema, you are suddenly on the whole different level. And just to give you example how it works in terms of the flow, so I have prepared another query which is called select all users. So I just added it to test. I will update just that one query. Update effectively created a data snapshot that wants to be done, and then baseline create the data. So now if I run a test, you will see we will have 10 tests actually done, and you can see again there's a sequential scan. It's a table with like 100 records, so it will always be sequential scan. But to show you what it can do is I will edit that query and change the order. So this is the contract one. As you can see, it not only tests the performance, but now it checks that the data is no longer correct. This is the regression part. So it actually checks the contracts on multiple levels. It's okay. If this would be a smaller data set, because I think it's 50 or something, or 10 rows from 1,000. If that is predictable, it will also write you, maybe you have a wrong order. It knows about the data, so it can analyze the data behind the scene. And you can do all this, and the goal is to create a fast. So I would say the difference between the big integration test is that this should be able to run in seconds, because the queries should be fast. You shouldn't wait for the database logic to be verified for 20 minutes. You should be able to do it in 30 seconds. So thank you for your attention. And are there any questions?